here we go.
Yeah.
Welcome to another episode of Containers from the Couch. My name is Cy Venom. I'm your host for today. Today we're going to be talking about Amazon Keyspaces for Apache Cassandra, and of course, as we do on Containers from the Couch, specifically for Amazon EKS. Michael, thank you so much for joining me today.
Thanks for having me. Great intro.
Awesome. Here we go. I love that song.
Yeah.
Michael, before we get going, tell us a little bit about what you do at AWS, maybe a little bit about yourself, and maybe what we're going to be talking about today as well.
Sure. Hi, everyone. Michael Rainey. I am a principal solutions architect here at AWS, working with NoSQL databases. I work extensively with Apache Cassandra and some of our managed NoSQL databases, such as Amazon Keyspaces, Amazon DynamoDB, Amazon DocumentDB. So all really things NoSQL and scale. My background is in development. I started developing on distributed systems probably about 12 years ago, when we started to need all the scale with the advent of mobile devices and a lot of websites coming online, inventories growing online. Needing those, large scale where traditional databases couldn't get you there. Been really working with a lot of distributed systems and helping customers really solve some challenging problems.
Awesome. Now, Michael, when I think about databases, really, they fall under two main categories, whether they're SQL-based or not SQL-based or NoSQL. Tell us a little bit about Cassandra itself. Putting aside AWS and Keyspaces and Kubernetes for a minute, what is Cassandra and what makes it an effective NoSQL database?
Yeah, absolutely. So again, when we started talking about scale, and we started to need large scale applications with a lot of data, we needed our databases to scale and scale horizontally. And Cassandra is really one of the first databases that really allowed you to do this at internet scale, allowing you to really do really quick lookups when you essentially repeatable queries. So I know what I'm looking up. I really want to just access that data which I'm looking up and get a really quick response time, and be able to grow that as my business grew as well. So if you think about it as in terms of a relational database where you plan your data model and then you start working backwards and working on your queries, really optimized for storage. NoSQL started saying, hey, this is my query. I need to model my data to represent a fast response time for my query, and really optimized on CPU, right? So you're able to send a lot of queries really quickly without wasting a lot of CPU on things like joins, and a lot of heavy operations. So this started putting a lot of control into the developers' hands, right? When I first started working with databases, relational databases, someone would design the schema, someone else would sort of operate it, and as a developer, you would sort of just make the best query you could and ask for an index once in a while. Once we started going to NoSQL, developers started taking a little bit more ownership of that data model.
All right, that makes a lot of sense. And look, I was looking back to when Apache Cassandra was initially released, and I saw it was back in 2008. So well before the days of Kubernetes and Docker. I think C groups were initially kind of introduced in 2007, just around the same time as Cassandra. And the fact that it's 2024 and we're still talking about Cassandra means it's a very relevant and has kind of maybe aged well over the years here. Tell us a little bit more about that. Like, why is Cassandra still so popular to this day?
Yeah, let's go back to that time, 2008, right? What was the technology at hand when you were on-prem on your data centers, right? One, you were probably dealing with spinning disk, very difficult to make writes and tons of small writes. The network was less reliable. We really didn't have software-defined networking. So something had to be really tolerant to network partitions. And orchestration was tough, right? We didn't have containers. We didn't have all these nice orchestration frameworks. So having a single unit of scale, a node, was really helpful from an administrative perspective. Let me just deploy a node, and when I need more scale, I add more nodes and more boxes. So it became a nice unit of scale, some nice tolerance to network partitions, and then also worked with very commodity uh, hard disk drives.
Okay.
And again, if you think about scale and the chaoticness of it, why it still works today is because, again, things just improved, hardware improved, network improved, but all through that, Cassandra was able to continue to be a meaningful technology in terms of speed and be able to adopt new frameworks such as SSDs and, again, Kubernetes, which we'll get into, and software-defined networking and benefits of the cloud.
That makes sense. And now, Michael, I know that, today one of the goals is for us to talk about Keyspaces, but being in the Cassandra space, being so kind of intimately familiar with this material, I know you work with customers who are in kind of all phases of adoption with Cassandra, whether they're managing Cassandra themselves, or maybe they're, wanting to move it into Kubernetes where they can still kind of self-manage it. And then, of course, with Keyspaces being a more managed solution. So in my mind, I kind of see this as a journey from, the most overhead self-managing Cassandra to maybe the least overhead. Maybe let's start at the very beginning of that journey. Talk a little bit about Cassandra, especially from a perspective of customers managing it themselves.
Yeah, I guess really as soon as really, as Cassandra was created, people were running Cassandra on EC2, and just as long as the project has been running, right, we've been able to run it on EC2. And so at AWS, we have a lot of experience with running Cassandra workloads. As you see here, right, having it as open source, having it being a global data store, being able to replicate data across regions allows you to not only get data closer to the end customer, but also has additional resiliency in case there's a regional sort of challenge. Again, as people running on EC2, running it on ephemeral drives, started making use of EBS, and all of the technologies that have come along with the cloud, we've slowly started integrating it into the Cassandra ecosystem best practices in terms of operations.
Got it. Makes sense. As we see Cassandra, being used on EC2, I think you would agree that it probably needs the most amount of intervention to keep things running smoothly.
Yep.
Some of the concerns that come to mind are things like automatically scaling in response to load and that kind of thing. And while you can use things like auto scaling groups and other metrics and tools to do so, as you mentioned, there are orchestration tools that we have today that make these kind of things easier.
Yeah, absolutely.
Yeah, let's maybe talk a little bit about where we're seeing customers today.
Sure. Well, definitely. We'll just go back to that. In terms of managing that deployment, as you get more and more nodes, that can be difficult to manage, and to manage a cluster that gets bigger and bigger. So you want to sort of maintain a consistent configuration. You may have other applications that need to scale with your Cassandra cluster, whether it be monitoring or sidecar processes, and outside repair processes and external tools, all need to start to scale with this. So as we moved from sort of maybe self-managed databases and applications on EC2 and into a containerized world and Kubernetes orchestrated, ideally people wanted to start managing their Cassandra cluster in the same way that they manage their application.
Got it. And I know you've got a slide over here talking a little bit about Cassandra on EKS. What is, and I know this is the weirdest word to look to figure out how to pronounce, but let's say K8 Sandra.
Oh yeah. And maybe if we would go back a slide before here, just talk few more things, right? Obviously, like you said, you've got a lot to orchestrate here. And there's additional processes, right? The Cassandra Reaper for managing repairs. Repairs keep your data and your queries operating quickly as it prepares the data, gets rid of duplicates, consolidates on the latest, let's say, replica results, and then also things like monitoring. These are all things that you have to orchestrate with your Cassandra cluster, as well as manage configurations. So now when we go back to and we look at Cassandra, K8 Sandra, we sort of have this operators to help us actually do some of the cluster scaling, sort of a unified way to scale your applications and your database, a sort of unified way to configure those instances as well. And then again, also couple the things you need to scale with that database. So whether it's that Reaper process or your backup process or your monitoring, and then maybe other databases like Grafana, Prometheus and Grafana you need to scale with your Cassandra cluster. The K8 operator allows you to do that, and you can leverage that on EKS. And many customers are leveraging this on EKS today.
Right. And it's like I was saying, it's part of that journey of, some customers might feel more, secure if they're already self-managing Cassandra and they've got the skills and they know how to do it. Then using something like Kubernetes to just streamline just a little bit of that operational overhead with K8 Sandra seems to make a lot of sense. I know that we had a blog published on this, and I'll share this in the chat. What do we talk about in this blog right here?
Really, it's to introduce a little bit into the Cassandra operator, but also to show you, if you are on EC2, how easy it is for you to scale up a cluster to 1,000 nodes. It really shows the power of that scalability and automation. This would take some operators maybe weeks to do, right? This really simplifies it, allows you to really go back to focus on the configurations and things that you want to scale versus a lot of time of redundant work of setting up additional nodes, etc. So this is a really great blog to read if you're interested in running Cassandra on EKS.
Yeah, in fact, we actually invited the the engineers from DataStax who helped build this kind of flow onto Containers from the Couch, I think over a year ago now. So I'll make sure that's linked in the description below on YouTube after this episode, so you can catch that as well. Definitely, that was a super interesting episode.
A great episode, yeah.
Yeah. All right, Michael, I flipped to the next slide here, and you can already guess what I'm going to ask you. So we talked about self-managing Cassandra, talked about K8 Sandra. What is Keyspaces, and where does that fit into the puzzle?
Right. So Keyspaces is a fully managed Apache Cassandra compatible database service that we here run at AWS for our customers. After hearing a lot of the challenges that customers had running their Cassandra workloads, we wanted to take a look at this problem, see if we can help customers take that burden off their shoulders of managing those clusters and the performance of those clusters, and allow them to scale and focus back on their business. So Keyspaces is serverless. We don't essentially have a number of nodes or configurations that you need to look at. We essentially use things like write units and read units, and we're able to scale that to millions of operations per second, whatever sort of your application needs. What we try to do is provide you with consistent latencies so that when you're starting out with your application and you're doing 10 operations per second, we want you to be able to get to millions of operations per second and still have those consistent latencies as you scale. We also want to provide that enterprise experience involving making sure that the data is secure, that it's encrypted, that it's compliant, and also highly available. So the services has 4 nines of availability in a single region. And in our multi-region deployment mode, which we released earlier last year, you can deploy in 5 nines of availability across multiple regions on AWS.
Got it. Got it. Okay. So I know that you're going to be demoing this today. So I won't kind of give away too much of that yet, but I'm fairly certain you're going to be showing us that insane performance that we can get from Keyspaces and that scalability. I did have a question. We call Keyspaces Cassandra compatible instead of just saying it's a managed Apache Cassandra instance. And so I've got to ask you, why are we coining it that way?
Yes, it's Cassandra compatible. We don't support all of the features of Apache Cassandra has today. Some features we want to make sure that they're scalable and reliable before we bring them into the ecosystem. And we also wanted to customize it with some things like point-in-time recovery, as well as bring in some additional performance characteristics around Cassandra repair and compaction.
Makes sense. And Michael, I'm going to bump the slides here, and feel free to bump it yourself as well. I know I want to make sure we can talk a little bit about the open source side now as well.
Sure. So what I see is that, and even broadly speaking, across AWS, we really have this really cool ability now to bring that open source stack that we've been developing on for 10 years, right, with our skill sets, into AWS and have it fully managed. So not only as your Cassandra workloads can run on AWS with your existing applications and your existing tooling, but you can run things like your Spark jobs in Glue or EMR serverless. You can run your Kubernetes work in EKS. You can even do manage Kafka, and even as well as Elasticache, having Elasticache serverless and for Redis. So it's really great that we can take our open source work and our applications that we've been building, run them on fully managed, and really take the best parts of AWS in terms of our resiliency and security and scale and things that we make us more agile and be able to develop quicker. So I really like this trend and where it's going, and really trying to build some nice customer stacks using open source frameworks and fully managed AWS services.
That makes a lot of sense. And in the world of EKS, we're no stranger to this. I think a simple analogy here is, yes, Amazon EKS is our managed service. It's our kind of iteration of Kubernetes, but we're using upstream Kubernetes. That means while we might be taking it and kind of repackaging it into our Amazon EKS distro, you can still use the CLI tools like kubectl to work with Kubernetes. So I think in many ways it's similar, where we're leveraging kind of open source applications and tooling, coupled with that resiliency and security that our customers have grown to love with AWS. Now I'm going to jump to the next slide here, and I love this slide. I know I took a sneak peek at these before our live show here. Tell us a little bit about how we're making Cassandra easier for our operations teams with democratizing.
Yeah, absolutely.
Yeah.
Maybe you can see on the left, right, we have, and really democratization means that really you're moving this capability and from the hands of a few to the hands of many, right? And we can see that there's a ton of settings for Cassandra. This is only a fraction of them in terms of what you need to really fine tune and make Cassandra really powerful in terms of performance. And traditionally what I've seen is that what happens is there's maybe one or two Cassandra, let's say, operators of the cluster, and the rest are sort of developers working with their tables within the cluster. But when we move to fully managed and we reduce the variables to read units, write units, it empowers developers to go ahead and create a table, be able to take ownership of the performance by reducing the read units or write units, and reducing the cost in that sense too. So the developer who would partner with system operators on a Cassandra workload can now do it themselves, right? They can go ahead and create a table going 10 operations per second, scale it up to millions operations per second. and they take a little bit more ownership in terms of performance and cost. But that is more empowering. They can move quicker, and it really allows a lot of people to now access the data tier. So I kind of mentioned it before. It's like when I started out with databases, you really couldn't touch the schema, you couldn't touch the database, you couldn't create an index, you couldn't, the things you couldn't do. You really just had to connect up and try to do your best query, etc. But now, when we move to NoSQL, now you take a little bit of ownership of the data model. Now you're designing the data model in Cassandra. And with a fully managed solution, we take it one step forward. Now you get to take ownership of performance and cost. And I've seen customers be able to, reduce their cost just by a simple change that resulted in reading less read units, right? So it's super empowering. You can really move quickly, and it's great for even just experimental, get going and tear down, right? So.
Yeah, no, and I think that's kind of one of the advantages here with that the team here has built with Keyspaces is by kind of abstracting away some of these more technical concepts, but then exposing the right bells and whistles and knobs so that users can get the type of performance that they want without necessarily having to know that deep level of knowledge, be inside that walled garden of here's exactly the set of things that you need to change to get what you want.
Yeah.
I really like that aspect of democratizing performance.
Yeah.
Okay.
You can think of on the left, there's probably 10 years of experience to get that all right. And on the left is 10 years, right? And on the right is probably, a few months of learning, how these read units, write units work.
Yeah, absolutely. Okay, Michael, I'm going to let you jump through the next few slides because I know what we want to talk about here is a little bit about how Keyspaces works behind the scenes, talk a little bit about the performance and the kind of expectations for our customers.
Absolutely. So Keyspaces capacity, right, on the bottom in the pink is what you're consuming, those read units and write units. And above is kind of like how we're allocating capacity. So really we learn how much capacity your table has based on its previous usage. So as you scale up, let's say to first 100 operations per second, 100 write units per second, we'll go ahead and say, all right, your last peak was 100 write units. We're going to scale up to 200 write units. So we'll double that capacity every time we sense a new peak for both reads and writes. So this is how we kind of allocates the right capacity to only meet new scales, new throughput, and unintended throughput spikes, but also maintaining consistent latency and performance.
And Michael, you're still only paying for what you consume, though, right? Regardless of the system being able to support this amount of throughput, you're really only paying for the purple line.
Absolutely. So you're paying in on-demand mode, you're paying per request. We have two modes, and then there's one where you pay for throughput and provision mode. So both is you only pay for what you consume, not for what we provision behind the scenes to allow you to do that.
Gotcha.
Which is really powerful. Many workloads, if you can think about it at scale, Black Friday and e-commerce, end of year or let's say tax season, you may need your peak capacity at that one point of year. Well, that will be waiting for you, right? And be able to scale up every year without essentially paying for all that capacity to sit around all year.
That makes sense. And that's the way it should be from a managed service. I like that.
Right. So just to illustrate that, right? So let's say for the last 10, 12 days, I'm doing some sort of throughput. I've reached some peak, but then some part of my business is going to take a break. Maybe it's a holiday season, maybe it's winter break. When I come back and business is full operational, that capacity is there waiting for me to really jump right back up instantaneously up to previous throughputs. And we're able to do this through our sort of service and really allow you to maximize in utilization of these partitions behind the scenes without having to sort of, like what you said, impact your bill.
Right. You don't want to, just because there has been a break, you don't want to have customer experiences be impacted with your backend waiting to scale up just because there was a break. No, that
Sure.
makes sense.
Yeah. So and again, scaling down, scaling up, these could be disruptive processes. Data has to move around. We have to deploy more partitions. So it's really effective. It doesn't have to do that. We just care about scaling up, right? So again, we have also ways. Let's say if your table, your table, you want to start at 100,000 operations per second. You don't want to start very small. You can go ahead and pre-provision a high throughput and then be at that level up front. So you don't have to start a table small either. It doesn't have to. You can skip some of the learning process by pre-provisioning enough throughput on the table up front.
Got it.
One other great quality is if you look at a Cassandra cluster, you deploy a cluster where it's on EC2 or EKS. Then you add all your tables to the cluster, and they all share the same resources. Well, different applications and different needs. You may have deployed microservices in your application tier. Well, what happens is that all of these microservices end up communicating with the same Cassandra cluster. And maybe I'm developer A. Do I have to know what developer B is working on? So there is some potentially someone generally at the Cassandra level has to understand about all of the application needs to be able to pre-provision and understand what is needed at a cluster level. Again, and then also adding nodes to the cluster provides throughput throughout the cluster. But if let's say table A is consuming most of the capacity, you can essentially send some capacity directly to table A. You can only grow the entire pool of the cluster itself. So in some cases, it becomes a point of contention and an ability to communicate with other people and other teams to sort of schedule and deployments. But we want to work more independently. I want to be able to deploy my microservice independently and isolated of other services. So Keyspaces has a really nice, I think, value to the service in terms of we have table level isolation. So instead of scaling clusters, you scale tables. So if I'm developing a user service, I can scale my user table independently of a threads table or product tables, etc. So I can deploy my table to match that capacity needed for that service. And one table cannot steal the capacity of another table. So an interesting thing that happens when you migrate from Cassandra to Keyspaces, Cassandra is a NoSQL, there's no joins, right? The tables aren't related anyway. So even using your existing model, you sort of instantaneously adopt this table level isolation without any impact to your application. Because again, you're not doing any joins across tables. So we could talk about the service architecture. So when you connect to Keyspaces, right, you're going to be using existing Cassandra drivers. That's because we're compatible at a protocol level. Your initial application will make a connection to the service and be routed to one of many endpoints in our service. It'll establish a connection, and then you will get some metadata about your account and the tables in that account. And then the driver can make requests against those same endpoints and access its tables. Those endpoints are not necessarily nodes. They're actually sort of network load balancers. So we can scale the number of connections and the number of requests without having to change the number of nodes with that visible to the driver. So generally in Cassandra, you would have to maybe scale your nodes up. The driver will pick up those new nodes and start load balancing those requests around those nodes. Keyspaces, what you'll see is the nodes are fixed. And that's because really we're going to send your request to a different tier to go ahead and distribute that load across a fleet of infrastructure that supported your tables.
Got it. So it makes it a little bit easier for consuming or sending requests to the database itself because you have that fixed endpoint. You don't have to worry about load balancing requests. One developer doesn't have to know about another. One app doesn't have to know about each other. It's you stick with that one credential set.
Absolutely. Obviously, we do support IAM integration. So we plug into existing IAM roles, and you can actually keep the same role that your EKS app is using, leverage it to access your tables and manage permissions at the role level, down to the table level. At a higher point of view, after you come in through those endpoints, what you'll see is that we'll distribute your table data over multiple availability zones. And every time you write data, we'll store it in at least 2 replicas, and then 1 replica will be updated asynchronously. On the read side, you'll be reading from the latest replica data in the strong consistency read. Eventual consistency reads can actually read from any replica. And the benefit, traditionally a benefit of eventual consistency in Cassandra, maybe there's some availability improvements, maybe there's some performance improvements, but it's a little bit hard to determine what that would be. But since eventual consistency in Amazon Keyspaces uses half of the capacity of a strongly consistent read. So this is where, again, developers have a lot of power and to be able to controlling not only the amount of capacity and cost they use by using eventual consistency or making choices at the developer level. Cool. And now let's, I believe.
Is it time for the demo?
We're ready for a demo. Everyone's waiting for it, right?
Let's see it.
So this is a simple demo. I go from about 1 to 40 pods in EKS. I have about 6 M2X large nodes, I believe, in my EKS cluster, which deployed within my private VPC. I will be communicating through Keyspaces private VPC endpoint. That essentially allows you to communicate privately from your VPC to the Keyspaces service. And then again, my Keyspaces service was newly created, deployed, and we'll be scaling as the number of EKS pods grow. They're each doing about 2,000 operations. 4,000 operations each. 2,000 writes, 2,000 reads. It's a mixed workload. So we'll go up to 80,000 writes, 80,000 reads, and about 160,000 total transactions per second. And we're doubling it about every 5 minutes. I kicked it off before we went to started this session. So hopefully we're coming to close to the end now. But again, we'll see. We're also behind the scenes. We're leveraging a lot of those native services, right? EKS is using EC2 instances. We're using IAM for authentication. Metrics for Keyspaces is being sent to CloudWatch, and any sort of administrative event is going to CloudTrail. Even a DML operations you can send to CloudTrail as well. Again, the fully managed and fully operational, not scaling any of the nodes in the background, letting the system kind of take a handle over.
Okay, cool. Michael, if you're ready, I'll bring up your screen now for the demo.
Yeah, sure. Let's bring it up.
All right.
I'm not even sure what's going on right now. Okay. All right. So
you said you kicked this off right when our live stream started. So it should have been kind of increasing the amount of read write requests every second. Yeah.
So let me see. Jump onto my screen here. Yeah. So you can see that we've scaled up to about 80,000 read units.
Hey, Michael, not to interrupt you, but would you mind taking the screen back to the previous size? It all became a little bit smaller.
Sorry. How about that?
Make it a little bit taller and yeah, and maybe zoom in a bit.
Zooming in a bit.
Yeah, that looks good.
Okay, sorry about that. Yeah, so I've been doing a few different runs, kicking off the job, and essentially, right, as the number of pods doubled, we've also doubled in the number of throughput. and the table has been scaling. I originally deployed this table with about 20,000 pre-provisioned write units and 20,000 read units. Given sort of the length of this test, that if you can imagine that imaginary bar that we've seen previously, you probably see some additional capacity being added for every one of these, like every time it reached new peaks. Right now, we just have the total operations per second here, 127,000. And this is scaling up to 160,000 total.
Michael, real quickly, we're looking at, is this a CloudWatch dashboard that's created? Is this like a dashboard you created, or does this come automatically with Keyspaces?
So I'll see if I could share the link, but this is a CloudWatch dashboard that I created. It's available on GitHub. You just deploy it through CloudFormation, and it will deploy all of the Keyspaces metrics for you. So whatever is not available in just the Keyspaces console, you can use this template to deploy it for a Keyspaces table or Keyspace to sort of visualize, all of the metrics that we have available. And I'm always updating it so that, as we get new features and new graphs and new metrics, I'll add it to that dashboard as well.
Okay, excellent. Yeah, if you can find a link for me, I'm happy to drop that in the chat for folks. Now, Michael, I've got to ask you, as we bumped up the number of requests, and we're assuming, Keyspaces is scaling up in the back end, did we ever see a drop in performance? Did the latency ever go up, or are we seeing solid latency all the way through?
Let's see. I hope we're pretty solid. Yep. So you can see that writes are about 2.5 milliseconds. Reads are about 1 millisecond. And these are sort of key value lookups based on this data. But the data is totally randomized. So it's not something like this is the latest data that it's reading. As these writes are happening against the table, this can be from any sort of the data set itself from Keyspaces. Keyspaces doesn't cache any results in the service itself. So everything is sort of a direct read from disk. But from that, we're actually able to help reduce and we fine tune for those cold access points and P99s related to, when you get out of cache and memory and into disk. So we sort of optimize for that.
Got it. Awesome. Love to see that.
We actually, and through the scaling process, right, we'll even see that we jumped in and we had some system errors. System errors will periodically happen. This is sort of behind the scenes, whether it be something like we're scaling capacity and we're adding new capacity and had to take something out for a bit. There may be a timeout. There may be something on our end. So system errors are something that's generally transient and you can retry through. If you were to make more requests, like let's say you created a new table and you started hitting it with 1 million operations per second, what you'll generally see is, although there's no data here, read and write throttles. So if you maximize the actual capacity on a table, will actually reject the request, which is a very interesting trade-off. Generally, if you overload a Cassandra cluster, adding more throughput than the nodes you have available, what happens is your queries tend to slow down, and all of the queries slow down, right? As the resources and your CPU reaches 100%. Keyspaces, you'll be able to consume 100% of capacity we've allocated for the table and provide consistent performance there. But if you request more capacity to know what the table is there, we'll reject that request with a write throttle. Behind the scenes, the service looks to add capacity where it's needed. So it's actually going to say, hey, there's been a lot of requests towards this key range. I need to add some more capacity there. So instead of scaling capacity at a global level, we actually target where the capacity is needed, which allows us to really fine tune how we scale a table, but also try to get to that scale quickly.
Got it. Got it. That makes sense. Now, Michael, you mentioned earlier that Keyspaces is kind of deeply integrated with AWS. You showed services like CloudWatch, CloudTrail, that kind of thing, and even just the console experience for Keyspaces would be cool to see. Is there anything like
Yeah,
that you can show us while we're here?
absolutely, sure. So I'll go into the Keyspaces console. And on the dashboard, overall here on the dashboard, I can see the performance metrics at a very high level across all of my tables. I can see some errors that I've hit. I can jump into my key spaces. I have different tables for a single region, and some key spaces are for multi-region. So if you create a multi-region key space, any table that you add to that key space will be also multi-region. So you can manage multiple tables, whether they're multi-region or not. I can jump into I can jump into the table that I have deployed today. Generally, storage will be updated about every 3 to 6 hours. Currently in on-demand mode, which we mentioned before, is a pay-per-request mode. And in my table, I can actually view my data model, essentially as a account partition key, which is the how you look up data by partition key. Additionally, there's a sort key or clustering key for a user, and then there's a blob for details of that user. What's interesting is I can see too that I don't have point-in-time recovery turned on. And point-in-time recovery allows you to back up your data and in a 35-day window and be able to restore it down to the second in terms of granularity. So in terms of managing this, I can go ahead and go to backups. See, it's off right now. I can go ahead and turn this on. And now I have point-in-time recovery enabled for the table. There's going to be no performance impact to that. But now I have this additional capability where I can now restore data in the case of, hey, someone deleted a table, or if data got corrupted. I can go down to the second, hey, last Tuesday, 12:04 p.m., let me go get that data set, restore that information, and figure out what has changed. Or if it's restoring the table, I can just restore the latest copy of that table.
Got it.
Yeah.
Was there anything else you wanted to show in this console specifically? Because I wanted to shift gears a little bit, but I'll pause here.
Let's shift gears. I like shifting gears.
Awesome. Let's do it. So I've got to ask, you mentioned you have pods that you're scaling in Kubernetes. Now, to configure Kubernetes to work with Keyspaces, I'm going to assume you have to do things like, setting up the IAM roles and that kind of thing. So your Kubernetes, pods are able to communicate with Keyspaces and all of that good stuff. And then in your pods themselves, how exactly does it work? I imagine you have some application code that's maybe using a Cassandra driver to connect to Keyspaces. Can you talk through that flow a little bit?
Yeah, so you use the existing open source drivers. We have a plugin that will use IAM authentication with those drivers. So in many of the drivers, it's a simply app configuration change, a file configuration change. Some applications, it may be a single line of code change to import that library. And that library is available in Java, Go, Python, .NET, Ruby, you name it, whatever there's kind of Cassandra driver, we have generally an integration there for IAM. It can use IAM roles, so it can use the role from that, let's say that node role, to actually access Amazon Keyspaces. And you essentially just configure that role to have the privileges for a table and a key space, and you're sort of ready to go as long as that let's say Java application is able to access the role of that underlying node.
Gotcha. Now, Michael, I'm going to kind of put you on the spot here, but very recently we released a feature in Amazon EKS called EKS Pod Identity, and it's the kind of natural successor to IAM roles for service accounts. Now, of course, to use Pod Identity, you have to have support in the SDK. Now, I'm going to assume this, but I'll ask you first. Do the data stacks, the Cassandra drivers, do they support the new Pod Identity based approach?
I do not know. I'll have to get back to you on that. It sounds interesting. We are integrated with the SDK, but we do use the SIG v4 authentication method. So that is the way that we go through to get this, let's say, roles or IAM users. But I'll have to double check on that specific capability.
So I will say, and I was definitely putting you on the spot there, but Pod Identity is kind of this natural successor to IAM roles where it allows our kind of operators, our EKS developers, to connect up IAM roles in Kubernetes service accounts to the services that they need to access without needing to go through kind of some of the heavy lifting of creating an OIDC provider and that kind of thing. So
okay.
Here's the first official feature request here on Containers from the Couch. Let's get
Awesome.
the SDKs to support Pod Identity. I think it'll drive a better experience for EKS users as a whole.
Well, yeah, look out for our example repos in the next few weeks, because I know one of the things that I love to do is make that first experience for customers easier, and especially getting the right roles and managing security easier from an application standpoint is always a win. So I'll definitely be looking to test that out.
Awesome. Now, Michael, before I let you go today, I want to give you a chance. Is there anything else that you wanted to demo, share with our users, viewers today? Maybe how they can get in touch with you, or how they can kind of get more acquainted with Keyspaces or Cassandra as a whole? Any last comments?
Sure. Yeah. Feel free to reach out to me directly on Twitter or LinkedIn. As well as if you want to go in a deep dive session, we have great immersion days to walk you through in detail and in depth about using the Amazon Keyspaces service for your Cassandra workloads. And come see us at AWS events in our sessions. Awesome.
Thank you so much, Michael, for joining me today. This was an awesome overview of not just Keyspaces, but Cassandra, K8 Sandra. We got to see that cool demo as well. Really appreciate you taking the time to prepare the demo and the information for us. Thank you so much.
Thank you for having me, and look forward to some more open source workloads in the future here.
Awesome. Now, for our folks viewing at home, be sure to subscribe to Containers from the Couch on YouTube, or follow us on twitch.tv/AWS if you want to see more content like this in the future. We'll catch you next time. Bye.
Cheers.